Okay, 12.3, Introduction to Probability. There's not a whole lot of new stuff in this lesson, so we're probably just going to do this one video. So we'll do our best, and then I'll make the determination if this is part 1 or if this is the only part for 12.3. So starting with theoretical probability. Theoretical probability is what we all know. Okay, it's the number of possible outcomes in A. So if we want an event to occur or not occur, out of the total number of possible outcomes, both the outcomes that we want to occur and the outcomes that we don't want to occur. So the theoretical probability is usually simply just called the probability. So example 1, finding probabilities of events. Standard deck of playing cards has 52 playing cards with 4 suits of 13 different cards of each suit. So ace through king of spades, hearts, diamonds, and clubs. Okay, so those are the 4 suits. So it says find the probability of drawing a king. Now it doesn't specify a king of what suit, so we just need to know how many different ways there are to draw a king. So there's the king of spades, the king of hearts, the king of diamonds, and the king of clubs. So there are 4 different kings out of the total number of ways to draw a card. Well, there are 52 cards in the deck, so we have 4 out of 52 is our probability, which reduces to 1 out of 13. Example 2, probabilities with permutations or combinations. So it says there are 20 students in your gym class. Your teacher divides the class into equal softball teams. Okay, so there are 20 students, and we're going to divide the class into 2 equal softball teams. So that means that we know that there are 10 students per team total. 10 students per team. That's going to come in handy later. Your team draws names one by one to determine the batting order. What is the probability that 1 out of the 7 freshmen on the team will be chosen first in any order? Okay, so we don't care which of the freshmen, we just care that one of the freshmen is first. So the probability that one of the freshmen will be first, well, there are 7 chances for the event happening, so 7 possibilities for a freshman being selected first out of 10 students. Okay, and that can reduce, of course, to 0.7. Okay, or a 70% chance. Okay. Example 3 is experimental probability now. So we're talking about when we have actual numbers, we can determine what's called the experimental probability. So we're no longer talking about equal likelihood of an event occurring. We have to look and see what has actually occurred and then find out the probability from there. So it says that the exam scores are listed in the bar graph on the right. Find the probability that a randomly chosen student in this biology class received a B or better. Okay, so my B group is right here, and there were 11 students that got a B, and my A group is here. There were 5 students that got an A. Okay, the total number of students in the class, well, we've got our 11 and our 5, but then we've also got 1 student got an F, and 9 students got a C. So 1 F, 9 C's, 11 B's, and 5 A's adds up to a total of 26. So we have 26 total students in the class. We want to know just the ones that got a B or better, so that's an A or a B. So 11 plus 5 gives me my B or better over 26. Okay, so that would be 16 out of 26, which is approximately 0.615. On to the last example. Okay, so now we're dealing with probability with area. So we're using some geometry to figure out the probability of hitting a dartboard. So it says you throw a dart at a dartboard. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 15 points or 10 points? Okay, so 15 points is this area right here. Okay, and 10 points is the area around the outside. Now, at first glance, it looks like the area around the outside is probably bigger, but let's verify that. Okay, so the probability of each of the events occurring. So for the 15 points, we want to take the area of the middle square. So we want to take this area right here, which is 8 by 8. So that would be 64 square units, minus the area of the 20 pointer. So the 20 point is on the inside here. So we're going to subtract that from it, which is 4 by 4, which would be 16 square inches, out of the total area of the entire board, which would be the 12 by 12 around the outside. Okay, so out of 144 square inches. And that's going to give me a total probability of 64 minus 16, which is 48, divided by 144, which is approximately 0.333. Okay. Now, to find the area for the 10-pointer, we have to find the area around the outside minus the area of the middle square. Okay, and then take that out of the area of the entire board. So the area of the entire board is the outer one, that's 12 by 12, 144, minus the area of the middle square, which is the 8 by 8, or the 64. Okay, we're going to divide that by the whole thing, which was 144. Okay, and that gives us approximately 0.556. So obviously 0.556 is greater than 0.333, so we are more likely to get 10 points.